Now we'll come to conditional probability. Now, as the name suggests, this is probability of an event subject to some condition. So suppose we have two events, A and B, in sample space S, such that probability of A is unequal to 0, then we define conditional probability B by A. So this is a notation to write conditional probability. Now this doesn't mean set B divided by set A, because it doesn't make sense. B by A, it represents probability of occurrence of event B if event A has already occurred. So basically we are trying to find out probability of occurrence of this event B in case when the condition is given that event A has already occurred. So this notation B by A, it is neither division of sets nor division of probability of B and probability of A. It simply represents the probability of occurrence of this event B if we know that event A has already occurred. Now if we go back to the Venn diagram, this is event A and this is event B, and we know A has already occurred. So outcome is from this set A. Now we have to find the probability that B has occurred. Now if we know that A has already occurred, then the only chance of occurrence of B is if we have points from this region. That means its probability of B by A is probability of this favorable region, so which is probability of A intersection B upon this entire region, which is probability of A. So for conditional probability, if we have to write conditional probability of B, that is probability of occurrence of B if A has already occurred, it is given by this probability A intersection B upon probability of A. In the same way, if probability of B is unequal to 0, and if we have to write probability of A by B, which is probability of occurrence of this event A, if we know that B has already occurred, then this probability will be given by probability of A intersection B upon probability of B, and clearly P and PB, they are not equal. That means probability of A by B is generally not equal to probability of B by A. Now if we know probability of intersection, probability of events, we can calculate this conditional probability, and if we know conditional probability and probability of individual events, we can calculate probability of A intersection B. From this formula, we can write probability of A intersection B as probability of A into probability of B by A. And from here we can write probability of A intersection B as probability of B into probability of A upon B. So from intersection we can work out conditional probability, and from conditional probability we can work out intersection of events. And when we calculate A intersection B using conditional probability, we say this is multiplication theorem. So this is multiplication theorem of conditional probability. Now at this point you must be wondering, this A upon B or B upon A, it looks complicated, and why are we going to use it to calculate A intersection B? But once you know this conditional probability, you'll know that at times it is pretty easy to find conditional probability rather than calculating intersection of events. So what I'll do is I'll take a very simple case. Suppose we have two boxes. This is box 1 and there's this another box which is box 2. Now box 1 contains 4 red and 4 white balls, and box 2 contains 2 red and 6 white balls. Now it says a box is chosen at random and a ball is drawn. So we can choose either box 1 and then we can draw a ball, or we can choose this box 2 and we draw a ball from this box 2. We have to find the probability that ball drawn is red. Now we need a red ball. This red ball, it can either come from box 1 or it can come from box 2. So probability of getting this red ball, it depends on whether it has come from box 1 or it has come from box 2. So in this case, we clearly know we are dealing with conditional probability. So we have two cases. Case 1, when we have chosen this first box and then we have drawn this red ball, or we have chosen this second box and then from the second box we have taken this red ball. Now how do we find P1 intersection R? Now to find these probabilities, we'll use conditional probability. Now I'm going to ask you, what does this representation means? P R by first. Now this is conditional probability, and this probability means probability of getting a red ball if we know first box is chosen. So we clearly know that chosen box is first, and from this first box we have to get a red ball. So from this first box, if we have to get a red ball, what is the probability of drawing a red ball from box 1? So it has 4 red and 4 white. So probability of getting a red is 4C1 upon, and total we have 8 balls, it is 8C1. So this probability is 4 by 8. And the same way, if I am to write probability of R by second, it means if we know chosen box is second box, we have to find the probability of choosing a red ball. Now from this second box, probability of finding a red ball, it is simply 2 by 8. So it is very easy to calculate conditional probability in both the cases. Now if I'm going to ask you, what is the probability of choosing box 1? Now since we have two boxes, so we are going to assume condition of equally likely. So probability of choosing box 1 will be same as probability of choosing box 2, and this probability will be simply 1 by 2. Now we can use multiplication theorem to find these two probabilities. We can write probability of first intersection R will be probability of first into probability of R by first. So in this case, probability of first is 1 by 2 and probability of R by first is 4 by 8. So this is 1 by 4, and for this one, probability of second intersection R is probability of second into probability of R by second. So probability of second is probability of choosing this second box, which is 1 by 2, and probability of choosing a red ball from this second box, it is 2 by 8. So this probability is 1 by 8. So this conditional probability is not something which is very difficult. It's just a way of writing a probability with a given condition. And conditional probability is going to simplify the condition in most of the cases. So now we know conditional probability and we know multiplication theorem. Now using these two, we can define something called as total probability theorem. Now we are going to use total probability theorem for the cases where we have an event, and probability of that event, it depends on outcome of some preceding event. If A1, A2 and AN, they are mutually exclusive and exhaustive events, then probability of occurrence of any event A with A1, A2 and AN, it is given by this probability of A, and we can say this A occurs with A1, so it will be this A intersection A1 plus A intersection A2, A intersection AK and A intersection AN, or we can simply write this in summation terms. So this is probability of A intersection AI for I varies from 1 to n. Now we can write this using multiplication theorem as this summation I varies from 1 to n, and this is probability of AI into probability of A upon AI. So to calculate probability of any event A whose probability will depend on some previous mutually exclusive and exhaustive events A1, A2, A3 up to AN, then probability of occurrence of A, it will be given by this total probability theorem as this summation I varies from 1 to n probability of AI into this conditional probability of A upon AI. Now let us take up an example. Say for example, there is a factory and it has 3 machines A, B and C. Now this machine A, it gives 60% of the products. This machine B gives 30% of the products, and this machine C, it gives 10% of the products. So total is 100% and nothing is common. That means these 3 events, they are mutually exclusive and exhaustive. Now it says it is known that 1% of products from machine A, they are defective. So of all the products coming from this machine A, 1% of them, they are defective. Now in case of B, defective products percentage is 2%, and in case of C, it is 3%. Now it says a product is chosen at random and we have to find the probability that product is defective. So we write this as some event, say D, and this event is product is defective. Now, how do we calculate this probability that product is defective? Now, probability of getting a defective product is different for all the machines. Machine A, machine B and machine C. Therefore, this probability of choosing a defective product, it is going to depend on whether it has come from machine A or it has come from machine B or it has come from machine C. So this event D, it depends on outcome of previous event, whether it has come from machine A, machine B or machine C. So what we'll do is we'll write this event D here. So this event is product is defective and it depends on its previous step, and previous step is it has come from either of the 3 machines. So we'll write all these 3 mutually exclusive and exhaustive cases here. So it can come from machine A, or it can come from machine B, or it can come from machine C. Now suppose this event is A, this event is B, and this event is C. Now what is probability of A? So probability of A is you have to find the probability that the product has come from machine A. Now machine A, it handles 60% of the production. So the probability that product is going to come from machine A, it will be simply 60 by 100. In the same way, probability that it has come from B, B handles 30% of the production. So this probability will be 30 by 100. And the probability that it has come from this machine C will be simply 10 by 100. Now we have to find product is defective. Now this defective product, it can come from machine A, or it can come from machine B, or it can come from this machine C. Now using total probability, we can write this as probability of A into probability of D by A, probability of B into probability of D by B plus probability of C into probability of D by C. So corresponding to each event, we'll write their conditional probabilities. Now we'll write probability of D by A. Now what does that mean? It simply means that probability of getting a defective product if we know that it has come from machine 1. And the question, it is clearly given that 1% of all the products coming from machine A, they are defective. So probability of getting a defective product from machine A is simply 1 by 100. In the same way, it is given that probability of defective in case of machine B, it is 2%. So it will be 2 by 100. And probability of getting a defective product from machine C, it is 3 by 100. So now this probability of D, it is nothing but it is sum of product of these probabilities. So we have to multiply them and add them. So it will be this 60 by 100 into 1 by 100, 30 by 100 into 2 by 100 plus 10 by 100 into 3 by 100, which is 120. 120 plus 30 is 150. 150 by 1000. Now this is cancelled. Now this is 3 and this is 200. So the probability of choosing a defective product is 3 by 200. And this is how we use total probability. Now if we go back to our previous example of balls and boxes, in this case, we have to find the probability that ball drawn is red. Now this red ball, it can be either drawn from box 1 or it can be drawn from box 2. So this probability of drawing a red ball, it is probability of 1 intersection R plus probability of second intersection R. 1 intersection R is 1 by 4 and 2 intersection R is 1 by 8. So this probability of choosing a red ball is 3 by 8. Now here the question is, we are given that probability of X is 1 by 3, probability of X upon Y, which is probability of X intersection Y upon probability of Y, it is 1 by 2, and probability of Y by X, which is probability of X intersection Y upon probability of X, it is 2 by 5. Now since we have probability of X, then from this first and third we can calculate probability of X intersection Y, and this probability will be Px into 2 by 5. So it will be this 2 by 15. Now once we have X intersection Y and we put it in this second one, we get Py. So this Py, it will be 2 times Px intersection Y, and which is 4 by 15. That means this option D, it is correct. Now once we have all three values, we can calculate P X union Y. Now this is Px plus Py minus Px intersection Y, which is 2 by 15. Now this is 1 by 3 plus 2 by 15, which is 7 by 15. That means this option C is incorrect. Now Px intersection Y, it is 2 by 15, not 1 by 5. So that means this P is also incorrect. Now we have to find P x naught upon Y. Now P x naught upon Y is P x naught intersection Y upon probability of Y. Now this is probability of Y minus probability of X intersection Y upon probability of Y, and which is nothing but 1 minus probability of X by Y, which is 1 minus 1 by 2, and that is 1 by 2. That means option A is also correct. So the correct options are A and D. Now here the question is, let EC denote the complement of an event and let E, F and G be pairwise independent events such that PG is greater than 0 and probability of E intersection F intersection G is equal to 0. Then we need to find this probability that E naught intersection F naught upon G. Now we can write this as probability of G intersection E naught intersection F naught divided by probability of G. Now if we look at this Venn diagram of G, E and F, that means we are looking at the portion of G which is common to E naught and F naught. So we are talking about this region. Now this region, it is given by probability of G minus probability of G intersection E minus probability of G intersection F and plus probability of G intersection E intersection F divided by probability of G. Now probability of E intersection F intersection G, it is 0. Now we can write this as probability of G. Now since E, F and G are pairwise independent, so we can write this as probability of G into probability of E minus probability of G into probability of F divided by probability of G. Now this probability of G will cancel, so we can write this as 1 minus probability of E minus probability of F. Now we can write this as either PE dash minus PF or PF dash minus PE. So it will be this option C. Now here the question is, a bag contains n plus 1 coins in which n coins are fair and then we have one two-headed coin. Now one of these coins is selected at random and tossed. The probability that the toss results in head is 7 by 12. Find the value of n. Now this result, it is going to depend on whether it is a fair coin or whether it is a two-headed coin. Now the probability of selecting a fair coin is n upon n plus 1 and probability of selecting two-headed coin is 1 upon n plus 1. Now if it is fair coin, then probability of getting a heads, it is 1 by 2, and the second case probability of getting a heads is 1. So the total probability of getting a heads in this case will be n upon n plus 1 into 1 by 2 plus 1 upon n plus 1, and this probability is given as 7 by 12. Now we can write this as n plus 2 upon 2n plus 1, it is equal to 7 by 12 or 7 by 6. Now this is 6n plus 12 and this is 7n plus 7. So value of n here is 5. So number of tosses in this case should be 5, and that's your option A. Now here the question is, if E0 and F0 are complementary events of E and F and probability of F lies between 0 and 1, then which of the following is correct? Now this is a standard result. Now here we have F same, so we'll try this A, and this A is probability of E upon F plus probability of E0 upon F. Now this is probability of E intersection F upon probability of F, and this is probability of E0 intersection F upon probability of F. Now this is probability of F, and here it is probability of E intersection F, and this is probability of F minus probability of E intersection F. Now I'll cancel. So this probability, it is equal to 1. Now here also we have this F0 same. So we'll try this D also. So this D will be probability of E by F0 plus probability of E0 by F0. Now this is probability of E intersection F0 plus probability of E0 intersection F0, and this is probability of F0. Now we can write this as probability of E intersection F0, and this is probability of F0 minus probability of E intersection F0. upon probability of F naught. Now these two will cancel. So this again is 1. So the correct options are A and D. Now here the question is, let A and B be two events defined on a sample space such that probability of A is 0.4, probability of B is 0.8 and probability of A naught upon B naught, it is 0.1. We need to find this probability A naught union B. Now first we'll simplify this first condition. Now for this we can write probability of A naught upon B naught will be equal to probability of A naught intersection B naught upon probability of B naught, and this value is 0.1. Now probability of A naught intersection B naught will be probability of A union B naught upon probability of B naught, and probability of B naught is 0.2. So we can write 1 minus probability of A union B will be equal to 0.02, or probability of A union B is simply 0.98. Now once we have probability of A union B, probability of A and probability of B, we can work out probability of A intersection B will be probability of A plus probability of B minus probability of A union B. Now probability of A is 0.4 plus 0.8 minus 0.98, so there will be 0.22. So now we have probability of A, we also have probability of B, we have probability of A union B, and we also have probability of A intersection B. Now this first part is we need to find probability of A naught union B. Now we need to find probability of A naught union B. Now we can solve this using algebraic methods, and we can also solve this using Venn diagram. Now suppose if we take this sample space and we have A and B, now it says we need to find probability of A naught union B. Now A naught is everything else other than A, and then union B, which means this part. So we have to find probability of this shaded region. Now before that, what we'll do is we'll find this probability. So this probability, say P, it is probability of A minus probability of A intersection B. Now probability of A is 0.4 minus probability of A intersection B is 0.22. So there will be 0.18. Now this probability of A naught union B, it is nothing but it is complement of this probability. So it will be this 1 minus P. So it will be this 1 minus 0.18, and there will be 0.82. So answer to this first part is probability of A naught union B is 0.82. Another way of solving this question can be, we can find P A naught union B as probability of A naught plus probability of B minus probability of A naught intersection B. Now this is probability of A naught plus probability of B. Now probability of B intersection A naught is probability of B minus probability of A intersection B. Now here probability of B will cancel. Now probability of A naught is 0.6 minus, and it is minus minus plus, and probability of A intersection B is 0.22. So it will be simply 0.82. So either we use graphical method or algebraic method, we'll end up getting the same answer. Now the second part is we have to find this probability, that probability of A naught intersection B union A intersection B naught. So we need to find probability of A naught intersection B union A intersection B naught, which is probability that exactly one of them happens. And this probability, we know that it is equal to probability of A naught intersection B plus probability of A intersection B naught. Since these two events, they are mutually exclusive. Now this is probability of B minus probability of A intersection B, and this is probability of A minus probability of A intersection B. So it will be this PA plus PB minus 2 times P A intersection B. Now probability of A is 0.4, probability of B is 0.8 minus 2 into, and then A intersection B is 0.22. So there will be 1.2 minus 0.44, and which is 0.76, and that is the answer to this question. Now the question is, a number A is randomly selected from the set from 0 to 99. The number B is selected from the same set. The probability that number 3 to the power A plus 7 to the power B has a digit equal to 8 at its unit place. Now if we look at powers of 3, 3 to the power 0 is 1, 3 to the power 1 has 3 in the units place, 3 square has 9, 3 cube has 27, and 3 to the power 4 is 1. So these values, they are going to repeat after every 4 powers. Then the same way we look at powers of 7. 7 to the power 0 is 1. 7 to the power 1 is 7. 7 square has 9 in the units place. 7 cube has 3. And 7 to the power 4 has 1. Again, we'll have these values repeated after every 4 power. Now it says we need to find the probability that the number has digit equal to 8 in the units place. Now we'll get 8 in the units place if we choose 1 here, and then correspondingly we have 7 here. If we choose 9 here and we take 9 from this, or if we choose 7 from this and we choose 1 from this. Now if we look at values of A, then out of these 100, we have 25 sets of 1, 3, 9 and 7 each. So probability of choosing this favorable A will be simply 3 divided by 4. And once we have chosen A, then B is automatically chosen 1 out of 4. So it will be this 1 by 4. So the required probability is 3 by 16, and that's your option D. Now the question is, for any two events A and B, which of the following is true? Now the first one is P A by B. Now we know that P A by B is P A intersection B upon probability of B. We are given that probability of B is unequal to 0. Now we can write probability of A intersection B as probability of A plus probability of B minus probability of A union B upon probability of B. Now maximum value of A union B is 1. So it will always be greater than or equal to probability of A plus probability of B minus 1 upon probability of B. That means this option A, it is correct. Now if we look at this option B, it is probability of A intersection B naught. Now probability of A intersection B naught, it is clearly probability of A minus probability of A intersection B, because it is that part of A which doesn't contain B. So there will be probability of A minus probability of A intersection B. So option B is also correct. Now if A and B are independent, then we can write probability of A union B as 1 minus probability of A union B complement, and this is 1 minus probability of A complement intersection B complement, and we can write this as 1 minus probability of A complement into probability of B complement. That means option C is also correct. Now what about option D? If A and B are disjoint, then we can write probability of A union B as probability of A plus probability of B minus probability of A intersection B, which in this case will be 0. So it will be simply this PA plus PB, and we cannot write it in this form. So the correct options are A, B and C. Now the question is, two buses A and B are scheduled to arrive at a town central bus station at noon.
the probability that bus A will be late is 1 by 5 and the probability that bus B will be late is 7 by 25. The probability that bus B is late, given that bus A is late, is 9 by 10. We need to find other probabilities. Now we are given that probability that bus A arrives late, it is 1 by 5, and probability that bus B is late, it is 7 by 25. Now it also is the probability that bus B is late, given that A is late, it is 9 by 10. Now this probability is probability BL intersection AL upon probability of AL, and this is 9 by 10. The probability of AL is 1 by 5. So their intersection BL intersection AL will be simply 9 by 50. Now first we need to find this probability that neither bus will be late on a particular day. Now neither bus is late. That means probability AL naught intersection BL naught, and this probability is P AL union BL naught, and this is 1 minus probability of AL union BL. Now this is 1 minus PAL. This is 1 by 5 plus 7 by 25 minus 9 by 50. Now this is 1 minus 50, 10, 14, minus 9. So that will be 15 by 50, 3 by 10, which is 7 by 10. So this probability will be 7 by 10. That means this option A is correct. Now the second one is bus A is late, given that bus B is late. So we need to find this probability that AL by BL. Now this is probability of AL intersection BL upon probability of BL. Now AL intersection BL is 9 by 50 divided by 7 by 25. So this is 9 by 14. Option B is also correct. Now this third one is at least one of the buses late. Now in the first one we have already calculated this probability that neither bus will be late. So in C, this probability will be simply 1 minus the answer we get in this first part, which is 7 by 10, and it will be this 3 by 10, option C.
Today we'll be discussing JEE Advanced 2021 Mathematics Paper 1. Now the first question is, consider three sets E1, 1, 2, 3, F1, 1, 3, 4 and G1, 2, 3, 4, 5. Two elements are chosen at random without replacement from the set E1, and let S1 denote the set of these chosen elements. Let E2 be E2 minus S1 and F2 be F1 union S1. Now two elements are chosen at random without replacement from the set F2, and let S2 denote the set of these chosen elements. Now G2 is G1 union S2, and finally two elements are chosen without replacement from the set G2, and let S3 denote the set of these chosen elements. Now let E3 equals E2 union S3. Now if it is given that E1 equals E3, find the conditional probability of the event S1 equals 1 by 2. We need to find the value of this conditional probability. Now we are given three sets E1, and E1 is 1, 2, 3. We have F1, and F1 is 1, 3, 4. And then we have this G1, which is 2, 3, 4 and 5. Now first we choose two elements from the set E1 to form this set S1. Now we can choose this S1 in three ways. So this S1, it can be either 1, 2 or 2, 3 or 1, 3. Now it is given that E1 is equal to E3, and E3 is E2 intersection of S3, and E2 is E1 minus S1. So E2 is the remaining element from E1, and if E3 is equal to E1, it simply means that this S3, it must be equal to S1. So this S3, in the first case, it should be 1, 2. In the second case, it should be 2, 3.
and in the third case it should be 1 and 3. So we have three cases, case 1, case 2 and case 3. Now it says we are taking F2 which is F1 union S1. So we'll write F2 which is F1 union S1. Now in the first case this union will be 1, 2, 3, 4. In the second case it will be 1, 2, 3, 4. And the third case it will be 1, 3 and 4. Now from this we have to choose S2, and then from G1 union S2 we have to form G2, from which we have to select S3. Now since G1 has 2, 3, 4 and 5 and S3 has 1, 2, so in the first case this should have, yes, G1 intersection S2, it should have 1, 2, 3, 4 and 5. In the second case, when it is 2, 3, there can be two cases possible. Either it will be 1, 2, 3, 4, 5, or it will be 2, 3, 4 or 5. And in the third case, since it has 1 here, it should be 1, 2, 3, 4 and 5. Now in this first case, if we have to select these two elements in S2, then one of the element, it must be 1, and the other element, it could be any one of 2, 3 and 4. Now here also, if we choose this first case, then it should be 1 and then some element x. And if it is second case, then it should be some elements x and y other than 1. And in this third case, it should be this 1 and then some element x. So these are the four cases possible in which E1 is going to be equal to E3. Now we'll start calculating. Now in this first case, if we calculate this probability and say it is P1, then first we need to choose two elements from these three elements. It can be done in 2C2 upon 3C2 ways. Then from this set, we have to select S2 in such a way that 1 is always included. So total number of ways is 4C2, and if 1 is always included, then it will be 3C1. Now from this, we have to select S2, which is 2C2 upon 5C2. So this probability will be 1 by 3, and this is 3 by 6, and this is 1 by 10. So it is 1 by 60. So this first case, it is 1 by 60. Now before the second case, we'll calculate actually this third case. In this third case, suppose this is P3. Now first we have to select 1, 3, which again can be done in 1 by 3 ways. Now again for S2, we have to select two elements from these three elements. It can be done in 3C2 ways, and one of the element, it must be 1. So this other element, it can be selected in 2C1 ways, and then into these 2 out of 5. So it will be 2C2 upon 5C2. Now this is 1 by 3 into 2 by 3 into 1 by 10, and it will be 1 by 45. Now we'll come to this second case when we have this 2, 3. So this is P2, and it'll be this 1 by 3 into, now we have two cases. Case 1, if 1 is included, now if 1 is included, there'll be 3C1 upon 4C2 into, now from this we need to select 2, 3. So it'll be 2C2 upon 5C2 plus, and if 1 is not included, then it'll be any 3C2 upon 4C2 into, now this is 2C2 upon 4C2. Now it'll be 1 by 3. Now this is 3 by 6, and this is 1 by 10 plus this is 3 by 6 into 1 by 6. Now this is 1 by 2, so we'll take this 1 by 2 common. So it'll be this 1 by 6 and then 1 by 10 plus 1 by 6, which is 8 by 180, and which is 2 by 45. So this probability is 2 by 45. So in the first case, we get this probability as 1 by 60. In the second case, it is 1 by 45. And the third case, it is 2 by 45. Now we need to find this conditional probability that if E1 equals E3, S1 is 1, 2. So this required probability P will be given by P1 upon P1 plus P2 plus P3. Now this is 1 by 60 and it is 1 by 60 plus 1 by 45 plus 2 by 45. So this is 1 by 60. Now this is 1 by 60. Now this is 3 by 45 and 3 by 45 is 1 by 15. Now this is 4 by 60. So this probability will be 1 by 5. So the value of this conditional probability is 1 by 5 and that's your option A. Now question number 11 is, there are 4 distinct balls labeled 1, 2, 3, 4 and 4 distinct bins labeled A, B, C, D. The balls are picked up in order and placed into one of the 4 bins at random, and let EI denote the event that first I balls go into distinct bins. Now calculate the following probabilities. Now first is, we have to find this probability that event is E4, and when the event is E4, that means all the 4 balls, they went into different bins. So first we have to find total number of cases. So we have 4 balls and for each ball we have 4 choices. So total number of ways will be 4 into 4 into 4 into 4, 4 times. So it will be simply 4 to the power 4. And now if all the 4 balls, they go into different bins, then we just have to arrange these 4 balls in 4 places, and it can be done in simply factorial 4 ways. So this probability will be simply factorial 4 upon 4 to the power 4. Now second one is this conditional probability. We have to find probability of E4 when it is given that E3 has already occurred. So it will be probability of E4 intersection E3 upon probability of E3. Now what is E4 intersection E3? E4 intersection E3 is nothing but it is simply E4 and here will be simply E3. Now probability of E4 is factorial 4 upon 4 to the power 4, and probability of E3 is probability of the event that first 3 balls, they go into different bins. So first we have to select which bin. So it will be 4C3 and then factorial 3, and for the last ball we have 4 choices. So it will be 4 upon 4 to the power 4. So this 4 to the power 4 will cancel. Now this factorial 4 will cancel. So it will be simply 1 by 4. Now this third one is probability of E4 upon E2. Now it will be probability of E4 intersection E2 upon probability of E2, which again is probability of E4 upon probability of E2. Now this is factorial 4 upon 4 to the power 4, and probability of E2 is first 2 balls, they went into 2 different bins. So it will be 4C2 into factorial 2, and then for the remaining 2 balls it will be 4 square and then 4 to the power 4. Here this 4 to the power 4 will cancel. So we can write this as 4 into 3 into 2, and here will be 6 into 2 into 16. So this 6 will cancel, 2 will cancel, and this is simply 1 by 8. Probability of E4 upon E2 is 1 by 8. And then finally this probability that probability of E3 upon E4 will be probability of E3 intersection E4 upon probability of E4. Now probability of E3 intersection E4 is probability of E4 and it will be upon probability of E4, which is 1. So this is a sure event. So the required probabilities are factorial 4 upon 4 to the power 4, 1 by 4, 1 by 8 and 1. Now question number 52 is,
two coins are tossed independently where probability head occurs when coin I is tossed is Pi. It is given that at least one head has occurred. What is the probability that coin produced different outcomes? So we need to find this probability that it produced different outcomes when we know that at least one of them is a heads. Now when we say at least one of them is a heads, it will be probability of H1 plus probability of H2 minus probability of H1 intersection H2. Now, what is the probability that the coin produced different outcomes when at least one head has occurred? So either it could be first is heads and second is tails, or first is tails and second is heads. Now these probabilities, they are independent. So we can write probability of H1 as P1 and then probability of second tails is 1 minus P2, and in the same way it is 1 minus P1 and it will be simply P2 upon this is P1 plus P2, and then P intersection B is P into PB. So it will be P1 into P2. So we can write this as P1 plus P2 minus 2 P1 P2 upon P1 plus P2 minus P1 P2, and that's your option number B. Now question number 53 is the number of cars X arriving at a service station per day follows a Poisson's distribution with mean 4. So value of lambda is 4. Now it says the service station can provide service to a maximum of 4 cars per day. Then the expected number of cars that do not get service per day equals what? Now what we'll do is we'll define a random variable X equals I, and then we'll find its corresponding probability Pxi. And then we'll also define a random variable XR, which represents number of returned cars. If I is 0, then XR is 0. If I is 1, then again it is 0. So if it is 0, 1, 2, 3, 4, then number of returned car will be simply 0. But when we have more than 4 cars, now 1 will be returned, for 6 it will be 2, for 7 it will be 3, and then we have their corresponding probabilities, which are probability X equals 5, probability X equals 6, probability X equals 7. So we can write expected number of returned car will be 0 into Px equal to 4 plus 1 into Px equals 5 plus 2 into probability X equals 6, and it goes up to infinite, which we can write as I into P X equals I plus 4, where the value of I varies from 0 to infinite, and that's your option number C. Now question number 10 is the chance of student getting admitted to colleges A and B are 60% and 40%. So probability of getting admission in college A is 0.6 and probability of getting admission in college B is 0.4. Now, if a student is told that he has been admitted to at least one of the colleges, what is the probability that he has got admitted to college A? So we know that if A union B has already happened, we have to find this conditional probability A upon A union B. Now probability of A intersection A union B is simply probability of A, and here will be probability of A union B. So it will be probability of A, and then probability of A union B will be probability of A plus probability of B minus probability of A intersection B. Now getting admitted in any college, it is an independent event. So it says the colleges admit students independently. So we know that PA intersection B will be PA into PB. So we'll write this as probability of A upon probability of A plus probability of B minus probability of A into probability of B. Now what's probability of A? It is 0.6, and here it will be 0.6, 0.4 minus 0.6 into 0.4 it will be minus 0.24. So it will be 0.6 and 1 minus 0.24. So it will be 0.76. So it is nothing but 15 by 19, and that's your option number D. Now here the questions. 1 Indian and 4 American men and their wives are to be seated randomly around a circular table. Now total number of ways of distributing these 10 people on a circular table, it is given by factorial 9. Now we need to find this conditional probability that Indian man is seated adjacent to his wife, given that each American man is seated adjacent to his wife. Now say this event is I and this event is A. So we have to find this probability of I by A. Now first we'll calculate this probability that all American men, they are sitting adjacent to their wife. So here we have 4 pairs of American couples, and then we have Indian husband and Indian wife. Now we have to arrange these 6 objects on a circle, which can be done in factorial 5. Now each American couple, they can be arranged as factorial 2, factorial 2, factorial 2 and factorial 2 ways. So this probability will be this factorial 5 into factorial 2 to the power 4 divided by factorial 9. So it will be this factorial 5 2 to the power 4 upon factorial 9. Now we'll find this probability that I intersection A. Now in I intersection A, along with 4 American, this Indian couple, they are also together. So now we have 5 objects which can be arranged in factorial 4 ways, and then these 5 couples, they can be arranged in factorial 2 to the power 5 ways divided by factorial 9. Now we need to find this conditional probability that Indian couple is together, given that American men, they are with their wives. So this probability will be this factorial 4 into 2 to the power 5 upon factorial 5 and 2 to the power 4. Now this probability simply will be 2 by 5, and that's your option C. Now here the question is, a ship is fitted with 3 engines, E1, E2 and E3. The engines function independently of each other with probabilities 1 by 2, 1 by 4 and 1 by 4. Now for ship to be operational, at least 2 of the engines must function. Let X denote the event that ship is operational, and X1, X2 and X3 denote respectively the events that engines E1, E2 and E3 are functioning. Then which of the following is or are true? Now we are given that probability of X1 is 1 by 2, probability of X2 is 1 by 4, and probability of X3 is also 1 by 4. Now X is the event that ship is operational. Now ship is going to be operational if at least 2 of the engines are functioning. So it could be either X1, X2 but not X3, or X1, X3 but not X2, or X2, X3 but not X1, or all 3 of them, they are functioning, X1, X2 and X3. Now first we will calculate the probability that this ship is operational. Now this probability will be 1 by 2 into 1 by 4 into 3 by 4 plus 1 by 2 into 1 by 4 into 3 by 4 plus 1 by 4 into 1 by 4 into 1 by 2 and plus 1 by 2 into 1 by 4 into 1 by 4. Now this probability will be 6 into 8 divided by 32, which is 1 by 4. Now for the first one, we have to find this conditional probability that X1 is not operational, given that ship is operational. Now this is probability of X1C intersection X divided by probability of X. Now if ship 1 is not operational, it is only this third case. Now in this case, this probability is 1 by 32 divided by probability of X, which is 1 by 4. Now this probability will be simply 1 by 8. So that means this option A, it is incorrect. Now this option B is probability exactly 2 engines of the ship are functioning provided it is running. So probability of say E by X. Now will be probability of A intersection X upon probability of X. Now if 2 of them they are running, so it will be this probability for these 3 cases, which is 7 by 32 upon 8 by 32. So this probability will be simply 7 by 8. That means this option B is correct. Now C is probability that X if X2. So this is probability of X intersection X2 upon probability of X2. If X2 is running and ship is operational, it will be this first case, third case and fourth case, which is 5 by 32 divided by probability of X2, and probability of X2 is 1 by 4. So it will be simply 5 by 8. So that means this option C, it is incorrect. And then we look at this fourth case, which is probability of X by X1. So it will be this probability of X intersection X1 upon probability of X1. Now if X1 is running, it will be this first case, second case and third case. So it will be this 6 plus 1 7. So it will be 7 by 32 upon probability of X1, which is 1 by 2. So this probability will be 7 by 16. That means this option D is also correct. So the correct options are B and D, which is your option A. Now the question is, two events A and B are such that PA dash is 0.3. That means PA is 0.7, probability of B is 0.5 and probability of A intersection B is 0.3. Now we need to find this probability B upon A union B naught. Now this is probability of A union B naught intersection B upon probability of A union B naught. Now this is A and B naught, and if you are taking its intersection with B, so it will be simply probability of A intersection B, and we know that probability of A union B naught will be probability of A naught intersection B naught, or we can write this as probability of A intersection B upon 1 minus probability of A naught intersection B. Now this is probability of A intersection B, and we can write this as 1 minus probability of B minus minus plus probability of A intersection B. Now this probability is 0.3. This is 1 minus 0.5 plus 0.3, which is 3 by 8, and that's your option A. Now the question is, A and B are two independent events such that probability of A is 1 by 2, probability of B is 1 by 5, and since they are independent, probability of A intersection B will be PA into PB, which is 1 by 10. Now using this, we can calculate probability of A union B, which is probability of A plus probability of B minus probability of A intersection B. So that will be 6 by 10, and 6 by 10 is 3 by 5. That means option A is correct. Now since A and B, they are independent, probability of A by B will be simply equal to probability of A, which is 1 by 2. That means option B is also correct. Now if we look at probability of A upon A union B, then it will be this probability of A intersection A union B upon probability of A union B. Now A intersection A union B is probability of A. So it will be this probability of A upon probability of A union B. Now probability of A is 1 by 2 and A union B is 3 by 5. So this probability is actually 5 by 6 and that's your option C. Now if we look at this option D, then in option D we have this probability of A intersection B upon A naught union B naught. Now this is probability of A intersection B intersection A naught union B naught upon probability of A naught union B naught. Now if we look at this Venn diagram, A intersection B is this region and A naught union B naught is, now A naught is everything which is not A and B naught is everything which is not B. That means it contains all the region except this A intersection B. So there is nothing common in between the two regions. So this probability it has to be 0. That means this option D is also correct. So the correct options are A, B, C, D.
Now the question is, there are 4 urns. The first urn contains 1 white and 1 black. Second one contains 2 white and 3 black. Third contains 3 white, 5 black. And fourth contains 4 white and 7 black. The selection of each urn is not equally likely. The probability of selecting ith urn is I square plus 1 upon 34. If we randomly select one of the urns and draw a ball, we need to find the probability of ball being white. Now first we are given that probability of selecting any ith urn, it is I square plus 1 upon 34. Now summation of pi, if you're going to check, it'll be this summation I square, where I varies from 1 to 4, plus summation 1 which is 4 upon 34. Now this is n plus 1, 2n plus 1 divided by 6 plus 4 upon 34. Now this is 3 and this is 2. So it will be 30 plus 4, 34. This is 1. So choosing the urns is a mutually exclusive and exhaustive process. Now once we have chosen any urn, we need to find the probability of ball being white. Now probability of ball being white, it is this summation probability of ball being white and has been chosen from ith urn, where I varies from 1 to 4. Now we can write this as Pi into P W upon I, where I varies from 1 to 4. Now when the value of I is 1, this probability is 2 by 34, and from the first turn, probability of getting a white ball is 1 by 2. For the second one, it will be this 4 plus 1, 5, 5 by 34. And probability of getting white is 2 by 5. For the third one, this probability is 9 plus 1, 10, 10 by 34. And then getting a white ball is 3 by 8. Plus, when I is 4, it will be this 17 by 34 into this probability of 4 by 11. And this value, it comes out to be 569 upon 1496, and that's your option A.
Now here the question is, Mr. B has 2 fair 6-sided dice, one of whose faces are numbered from 1 to 6 and the second one whose faces are numbered 3 to 8. Twice he randomly picks one of the dice and rolls it. Given that sum of the resulting 2 rolls is 9, find the probability that he rolled the same dice twice is. Now there are 3 possibilities. Either he can roll this first die, which is say D1, twice. So it will be this D1 D1, or it could be D1 D2 or D2 D1, or it could be D2, D2. Now probability of choosing first die, it is 1 by 2, and choosing it again is 1 by 2, so it will be this 1 by 4. This probability is also 1 by 4. Now this is 2 times 1 by 4, so it will be 1 by 2. So these three, they are mutually exclusive and exhaustive cases. Now if he has thrown this regular die both times, then the sum could be 9 if it is 3, 6, 4, 5, 5, 4 and 6, 3. In that case, this probability will be 4 by 36. Now if it is D1, D2, then it could be 1, 8, 2, 7, 3, 6, 4, 5, 5, 4 and 6, 3. So there will be 6 cases. So then it will be this 6 by 36. And if it is both D2, then we'll have 3, 6, 4, 5, 5, 4 and 6, 3. So again it will be this 4 by 36. Now we need to find the probability that he rolled same dice twice. So that means either this case or this case. Now it's a Bayes theorem question. So this probability will be this 1 by 4 into 4 by 36 plus 1 by 4 into 4 by 36 divided by 1 by 4 into 4 by 36 plus 1 by 4 into 4 by 36 plus 1 by 2 into 6 by 36. Now this 4 will cancel. Now this is 3 and this 36 will also cancel. So this probability will actually be 2 by 5. And that's the value of m and n. Now we need to find the value of n plus n. So this n plus n will be simply 7, and that is the answer to this question.
Now the question is, there are 3 urns, red, white and green, containing as many red, white and green balls. That says a coin when tossed is twice as likely to come heads as compared to tails. So on this coin, probability of head is 2 times probability of tails. Now sum of 2 probabilities is 1. So clearly probability of getting a tails, it is 1 by 3, and probability of getting a heads is 2 by 3. Now it says such a coin is tossed 2 times. If both head and tails are present, then 3 balls are simultaneously drawn from urn 1. If head appears on both, then 3 balls are drawn in similar manner from urn 2, and if no heads appear, then the 3 balls are drawn from urn 3. Now we need to find the probability that 3 drawn balls are 1 each of different colors. Now suppose this is event A. Now it's a conditional probability question. So either the 3 balls, they can come from either urn 1, urn 2 or urn 3. So we have 3 events, urn 1, urn 2 and urn 3, and then this is your event A. Now probability of choosing urn 1. We choose urn 1 when both heads and tails are present. So we get 2 cases, either it will be this HT or TH. Now it will be this 2 by 9 plus 2 by 9, 4 by 9. So probability of choosing urn 1 will be 4 by 9. Now we'll get U2 when it is both heads, and if it is both heads, it will be HH. That will be 2 by 3 into 2 by 3, which again is 4 by 9. So probability of U2 is also 4 by 9, and this probability that both of them, their tails, will be simply 1 by 9. Now we'll find this conditional probability that if we have chosen urn 1, then we get all 3 different color balls. Now total number of balls in urn 1 is 6. So there will be 6 C3, and then we have 1 red, 1 white and 1 green. So there will be 2 C1 into 3 C1 into 1 C1. And this is 6, and here will be this 5 into 4, which is 3 by 10. Then the same way, probability of A by U2. Now in U2 we have again 6 balls. So there will be 6C3, and then here we have 3C1, 2C1, and then 1C1, which again will be 3 by 10. And for this third one also, we'll get the same result. It is 6C3, and here we have 3C1, 1C1, and 2C1. Same combination. So it will again be 3 by 10. Now we need to find this probability of A. Now this probability of A will be this summation probability of A intersection UI, where I varies from 1 to 3, and will be this conditional probability of UI into probability of A upon UI. Now this is 4 by 9 into 3 by 10 plus 4 by 9 into 3 by 10 plus 1 by 9 into 3 by 10, which again is nothing but 3 by 10. And this is 30%. That means your option C is correct. Now the question is, an artillery target may either be at point 1 with the probability 8 by 9 or at point 2 with the probability 1 by 9. We have 21 shells each, of which can be fired either at point 1 or point 2. Now each shell may hit the target independently of the other shell with probability 1 by 2. That's it. The number of shells must be fired at point 1 to hit the target with maximum probability is X. Then we need to find the value of X by 2. Now once we fire any shell, we can direct it either at this first target or at this second target. Now probability of choosing this first target, it is 8 by 9, and probability of choosing the second target is 1 by 9. Now suppose out of these 21 shells, we have fired X at this first target and 21 minus X at this second target. Now we need to maximize this probability of hitting the target. Now probability of hitting the target as a function of X will be given by, now probability of choosing this first target is 8 by 9. So it will be this 8 by 9, and we have fired X shells onto this first target. So at least one of them must hit the target. So what we'll do is we'll do it with the exclusion. So we'll take 1 minus, and none of these X, it hits the target. So it'll be this 1 minus 1 by 2 to the power X. Now in the same way for this target second, this probability is 1 by 9, and it is destroyed with the probability 1 minus 2 to the power 21 minus X. Now we need to find the value of X for which this probability is maximum. So what we'll do is we'll differentiate. So we'll find dp upon dx, and it'll be this 8 by 9, and it is minus 1 by 2 to the power X ln 2 plus 1 by 9, and it is minus 1 by 2 21 minus X ln 2 into minus 1. So it will be minus minus plus 1, and it should be equal to 0. Now we put it equals to 0. This 1 by 9 log 2 will cancel. So we'll get this as 8 into 1 by 2 to the power X. It should be equal to 1 upon 2 to the power 21 minus X. Now this is 1 upon 2 to the power minus 3. So we can write 1 upon 2 to the power X minus 3 will be equal to 1 upon 2 to the power 21 minus X. Now if we compare, we'll get this as 2X equals 24. Value of X is 12. So out of these 21 shells, 12 must be directed at point 1 and 9 must be directed at point 2 to maximize this probability of hitting the target. And here we need to find the value of X by 2. So if X is 12, the value of X by 2 is 6, and that is the answer to this question. Now here the question is, there are 3 bags B1, B2 and B3, and bag B1 contains 5 red and 5 green balls. Bag B2 contains 3 red and 5 green, and bag 3 contains 5 red
and 3 green balls. Now bags B1, B2 and B3 have probabilities of 3 by 10, 3 by 10 and 4 by 10 respectively of being chosen. A bag is selected at random and ball is chosen at random from the bag. Then which of the following options is or are correct? Now the first one is the probability that chosen ball is green. Now it will be green if it comes from first bag. The probability of choosing bag 1 is 3 by 10. Now from this bag 1, probability of choosing a green ball, it is 1 by 2 plus, now bag 2 is 3 by 10. Now probability of choosing a green ball, it is 5 by 8 plus third bag which is 4 by 10, and then here green is 3 by 8. Now this is 12 and 12, 24. 24 plus 15 is 39. So this probability will be simply 39 divided by 80, and that's your option A. Now B is probability that chosen ball is green given that selected bag is B3. Now if we choose this bag number 3, then probability of choosing a green ball will be simply a green ball from these 8 balls. So it will be this 3C1 upon 8C1, which is 3 by 8, and that's your option B. Now probability that selected bag is B3 and the chosen ball is green. So this probability that selected bag is B3 and chosen ball is green will be given by this probability of choosing third bag, which is 4 by 10, and then probability of choosing a green ball, which is 3 by 8. So it will be nothing but 3 by 20. That means this option C, it is incorrect. The probability that selected bag is B3 given that the chosen ball is green. Now this fourth one, it is Bayes theorem question. So for this fourth one, we have to take this case in the numerator. So it will be this case in the numerator, which is 3 by 20 upon this total case, which is 39 by 80. Now this is 4, so it will be simply 12 by 39, which is 4 by 13. That means this option D is also incorrect. So the correct options are A and B.